Awesome, cool. My name is Dane Laughlin. I'm the enterprise chair for today. And it's my pleasure to bring up Noble Vale. He works for Bristol Myers Squibb, and he's going to talk about their XR journey in biopharma. So come on up, Noble.
Thank you so much. It's good to see everyone today, and I will be presenting on the benefits and challenges of leveraging AR and VR in biopharma. So there's a lot of things that we really look to consider in this, and let's see here. So this is the outline of the presentation that I have today, and I'll look into why we leverage AR and VR in biopharma. We have the first step in utilizing augmented reality, and then we went through COVID-19, as everyone did, the hurdles that we had, the subsequent growth that we had using these devices, and then looking into other parts of mixed reality, VR, and et cetera, and all the challenges, considerations, and concerns that me and my team have gotten throughout the way. So I'll go right into it. Why do we look at utilizing augmented reality and virtual reality in biopharma? It's creating new ways of working, looking at collaborating at remote locations, transforming how you encounter tasks, documenting your work in new ways, and then the idea of adding graphics, videos, and et cetera to your surroundings to have that immersive learning to clarify steps in a process. And even in VR, looking at creating virtual environments for interaction, the ability to be hands-on from anywhere, wherever you are. So changing my mindset into believing AR and VR works in biopharma. I didn't think this was possible. I grew up as a gamer as a kid. My first system was a Super Nintendo. It evolved. I had a Game Boy. I saw gaming as fun, and AR and VR as something fun in this digital age. You know, I had a challenge that was given to me by my management, thinking outside of the box and saying, can AR and VR actually work in our space? Can it provide a benefit to the people that are working using this technology? And one thing that I wanted to do, and I thought of, is the idea of leveraging more of a person's 5 senses to stimulate learning, seeing, presenting information visually through AR, VR, and et cetera. Hearing sounds from what you have in a digital experience in VR, or even in recorded videos that you're watching, or touching. That's the concept of using VR, on-the-job training or virtual training, where you have virtual touching so people can mimic working in these different types of environments. And the hierarchy here is digitizing this type of data through what we call knowledge creation. I have a comparison here of a diamond showing that's all the data that you can get, but how to push that data into different digital platforms and converting it to knowledge, where it is knowledge that we can comprehend, whether it's from pictures, videos, visualizations, and et cetera. And we see in the next slide here, AR and VR can be that part of it to digitize the lab or manufacturing environments or even the office. So we can have communications performed in real time using the audio and visual aspects of AR and VR, thinking outside of the box, looking at implementing things such as wearables and being fully connected to get and understand this data in many different ways. So once I got buy-in from my organization, my company loves names. They wanted to think of a catchy name for the project, things like that. So I'll explain it in a sec that we utilize augmented reality first. So I named this project Argyle. It was short for augmented reality glasses in lab environments. As we grew, as we looked at the idea of all extended reality, I wanted to change the name, and I changed it to assisted reality gadgets in lab environments, just because my company didn't want me to change the name of it. But we wanted to change it mainly because we wanted to differentiate AR and VR. A lot of upper management and senior management, they would interchange AR, VR, Google Glasses, RealWear devices, everything like that. So it was definitely a hurdle to try and make sure we educate the senior management that we have in the company that these devices can do different things. So now I'm going to go into the idea of how we first evaluated and used augmented reality as the quote-unquote quick win here at Bristol Myers Squibb. So because we wanted to do a quick win, we thought AR was going to be better than VR. It was because in VR, we had to leverage a lot of different skill sets, such as 3D modeling, game development for these immersive experiences. And this can be utilized in AR, obviously. But for the initial proof of concept, it was not required. With what we were looking to do in the company with our use cases, we just initially used the basic capabilities of the technology, not necessarily AR or VR per se, but what was features on the devices, such as being able to voice record, being able to leverage the idea of being hands-free, and the concept of having real-time calls and video sharing. So this is one of the first partners that we had for the project. The company's name Apprentice. I'm from New Jersey, and they're actually really local to New Jersey as well. And we used a hands-free tablet or head-mounted device called the RealWear HMT1, and also we enabled the use through an iPad. So one of the reasons why we chose this vendor was that Apprentice actually had a lot of experience with Biopharma. They had people on the team that really understood a company like mine's, our initial needs, and understand the idea that you could have all this utility, but we had to really take into consideration the data that had to be encrypted, data security, and things like that. And they had a high-level understanding of what hurdles we had to go through with our IT and cybersecurity colleagues. The other device that we use is also a pairable iPad that Apprentice definitely enabled that use. So it has a larger viewing screen. It had uses in different areas of manufacturing and lab environments. It had the same applications Apprentice developed. We used it and mounted it on tables. We used it as standalone cameras. We had it as ways where people can just wheel it back and forth for easy view while they're doing their work. We wanted to implement this technology in a way that it wasn't a burden for them to use. It was really that assistant tool that we wanted to promote. So in this slide here, I explained the general use cases that we have. So the big one was remote monitoring and telepresence. Other ones that we're looking at is more for data capture. Since there's a camera on the device, look at barcode reading. Taking embedded data and being able to transcribe it into a document right away without someone needing to type it, someone needing to write it down is very fast. Voice to text. We would do a lot of work in manufacturing environments and labs where we're using both our hands. And because if we're going through a process that takes 10, 15 minutes and we don't want to stop, there's a lot of documentation that gets lost. A lot of operators that work for 10, 15, 20 years have that knowledge in their head, and once they leave, that knowledge is gone. So enabling a lot of these operators to take those voice notes as they're working, and it's not being a burden, then it emphasizes the idea that that knowledge can be transferable to other people that are reading the notes and reading the procedures that have been completed. The last one I mentioned is equipment and procedural SOPs or work instructions. So this is where we utilize the iPad as a secondary screen where we can have the text of a procedure or a work instruction with accompanying videos or accompanying images. So we take a full-page document, maybe separate it into 5, 10, 15 steps, and each step can have a clarifying image or video to provide that visualization to the operator that's working on how to perform the process. The benefits and capabilities, there was so much that we saw, which included the time savings and compliance during documentation. Also the time saving and money saving on travel. People didn't have to, obviously with COVID-19, travel away from their families and be in certain areas. They could have their eyes and ears in these different areas. Connecting with internal databases using barcode reading, where we can get chemical information and equipment is vital. Following procedures and work instructions with the text, photos, and videos, as I mentioned, was the big key. And overall, this project, we started it back in 2018. We started with just 10 devices for initial proof of concept, and preliminary IT assessments were performed, and then it's grown immensely due to the COVID-19 pandemic that has happened, and I will be talking about that now. So it created numerous challenges in development. I work in a large biopharmaceutical company. We still had a lot of research that was going on. We had a lot of our medicine still being manufactured. We couldn't stop that, even with this pandemic going on. We had, obviously, due to restrictions, we couldn't travel domestically in the beginning and even internationally. Process and tech transfers of how we create our medicine. We had a lack of real-time communication going on. People didn't have that infrastructure of providing real-time video in these environments. Maybe they just sent emails or sent messages, and going back and forth, this communication could take hours or weeks, and there were a lot of projects that were delayed because of that before we implemented this technology. People needed our medicine. We had to maintain these timelines. And the project Argyle, it really addressed all these concerns. So this is an example of what was done where we implemented the technology at a partner in Asia. My company actually wrote an external article about it, so you could always search for it on bms.com. But at a high level, the scientists in normal circumstances, they traveled internationally to monitor the process, to talk to the operators in these locations. This particular article talks about work that was happening throughout a 2-week period located in a partner in Asia. And this person who was actually located in the UK, she normally would travel there for 2 to 3 weeks. During the pandemic, she couldn't. She was able to monitor the whole process from the comfort of her own home. And she even mentioned that she had a good feel of the process, work similarly if she was on site. And this really was eye-opening to a lot of the different groups in my company. And even with the time difference, we considered the fact that if we couldn't watch it in real time, the platform has the ability to record videos, take images, so this can be viewed after hours. So people can review it very quickly in case there's any quick questions. Another example, which has been done multiple times, was a subject matter expert helping people set up equipment remotely, because we didn't want to have people, social distancing, people working from home, people working off-site. We wanted to really enable that. And BMS is a big proponent of safety and making sure that we go through all the proper precautions that we need to do. So we have features in the Apprentice application where we could put dots or augment circles during the video process so people can see clarifying steps and make sure that assemblies of certain equipment are performed correctly. One picture shows making sure that the fittings are aligned with the pieces of equipment because they could fall off while it's going through its normal motion, or clarifying steps by, like I mentioned before, circling something. The technology paid for itself, plus more, since the scientists did not have to travel. Now I'll mention here just real quick about the importance of having a good collaborator. We have a really good relationship with Apprentice, and with their experience, it really helped us get to that next level. We continued training core and new users all throughout this entire program. We had the flexibility to support last-minute requests because things always happen in the last minute, or there's a partner that really needs us to work on this technology, and we have to enable it, whether it's somewhere in the company in the United States, Europe, Asia, etc. We work closely with the new teams to enable that success, and they have a swift response to questions and problems since they're also working with a lot of fellow biopharmaceutical companies. We work with them closely on getting bugs fixed, getting feedback. They understand what we're looking for, and that is then implemented in their development plan for making it much easier for end users to go through and improving that user experience. So great collaborative relationships really help drive general innovation forward. So like I mentioned before, in this pilot that I had, we started with just 10 devices. Now we've grown to over 140 devices all throughout my company. And we've touched more than 28 different projects, 17 sites in the company. We have these devices at more than 8 external partners around the US and around the world. 10+ BMS medicines have benefited, whether it's in their tech transfer process, manufacturing processes, and et cetera. We've been able to procure devices, send them to partners, and get these groups set up and working. And in general, we have more than 1,000 users that have logged in and used a lot of this tech. So looking at what we've done in AR, now we're looking at the idea of other platforms, VR and mixed reality. So we look at the idea of, the end users began to ask, this technology is great, what else can we do with it? It is different, but people then started mentioning VR. We first wanted to make sure that we educated people and made them understand that AR is completely different than VR. And there's a lot of different skill sets, like I mentioned, that are involved. And we have the idea of immersive training, developing virtual environments. There's certain training that is obviously better to be more hands-on. And in this virtual training, it's great because we have some trainings that we do in the lab, where first, lab consumables, chemicals can be very expensive to just use for training purposes. And for safety, if you do some of these unit operations wrong, people can get hurt. So if you make a mistake in a virtual environment, these people are still considered safe. And we're not compromising that due to lack of training. And one thing that I look to do is create modules in these procedures that can simulate real-world problems. So then people can fix these problems in a virtual environment, and then when they experience it in the real world, they already know what to do. The other idea here is immersive data. There is a program that a bunch of people in BMS use called Nanomy, and it's essentially looking at molecular structures, being able to manipulate them, spin them around, look at different bondings, and you're able to collaborate with a lot of different people from real time and all around the world. So they can talk about the different bonds, they can talk about the data that they see and go into that next level. And this can even expand into data analysis. The idea of accessing information in a virtual environment and navigating through all the different process data, being able to sift through different pages in real time and having that communication going on. The device that a lot of people in my company have been looking at is Hololens, mixed reality. It's different. It has it doesn't have that small screen that the RealWear does, and people had the idea that they like actually having that screen in front of them where they can implant like different images and text right in front of them and not worrying about looking at a small screen or using an iPad. It's not a completely immersive environment, as I mentioned, because you can still see what's going on in front of you and then superimpose different images, or you could have different models that are overlaid on top of what you're seeing to help clarify steps or fix things. Some end users provided the feedback saying that they would rather have this type of headset. So in terms of that, now we understand that Microsoft has been developing more of a rugged device. And with that announcement of the rugged device, a lot of people in my company are looking into that idea of looking at this new technology and seeing if it can be implemented in different areas. Because some people may want to use the RealWear or use Apprentice or use Hololens or any other software company that wants to really enable the use. And that's what we're looking to do. We want to further evaluate these in different laboratory and manufacturing environments. Now, lastly, what I'm going to be talking about is implementation considerations, challenges, and concerns. One of the big things is user adoption. I'm in a biopharma company. This is not a technology company like an ARVR company per se. So you have people all across the spectrum that are either very tech savvy or not very tech savvy. An ideal situation would be for someone to just pick up a device and use it to how they want to. But we all understand you have to go through menus, you have to go through login screens, and et cetera. But for a lot of people that are not familiar with this type of technology, that sways them away from using it. So it's important to really work with your partners to try and make it, as the US Army says, keep it simple, stupid. The hardware setups can be time consuming, but it needs to be done. So maybe having different teams that can work on that and be able to give it to the end user can be the solution. And an end user experience, comfort. The comfort of wearing the headsets. How long can you wear a specific headset for? Maybe RealWear headsets are good for 1 hour, or HoloLenses, or different other types of devices that are out there, HTC Vive, et cetera. Maybe they can last longer for certain people, and then you look at the idea of experiences such as motion sickness. A lot of people that are first using the technology, we've had a lot of feedback talking about the motion sickness. Either it's looking at the developers of VR technology and making sure it doesn't cause that motion sickness, or even people that are wearing the headsets and broadcasting live, educating them that maybe they shouldn't move their head around and nudge it so much, and make sure that you have a clear screen. Or maybe there's something that can be developed like a gimbal for a headset that it doesn't have a lot of that nudging that occurs. So enabling safe use of the technology. Cleanability. We work in a lot of different areas, so the ability to sterilize and clean the equipment is important. Sometimes we have hazardous chemicals that either come in contact with the device, maybe something that UV doesn't necessarily clean all of it, because then you still have powder on it, so maybe it needs to be wiped down with certain chemicals. And we work in a lot of high safety rated areas that maybe we need intrinsically safe devices or explosion-proof devices. So it really depends on what hardware is available that can really enable us to do that. And for guidance on use and working areas for VR, this is obviously something new in the company. So we have to develop, virtual training rooms, make sure it's safe for people to be in those immersive environments and be able to fully experience the experience that they have. And then being distracted. This is one thing our safety group was talking about. The idea of distractions, like talking on your phone or texting while you're walking. Thinking of the ideas of maybe not walking while looking at menus on the devices, so you don't trip and fall, because safety incidents are one of the things that really stop a lot of projects, because at BMS, safety is one of their top priorities here. So one of the last things that I'll mention is a lot of the challenges and issues that we've had throughout this whole implementation. Simple things such as Wi-Fi signal and device connectivity. A lot of the Wi-Fi areas that we have in our company, if there is even Wi-Fi, we're only supported for text and email, not full video, 1080p, high definition streaming. So this is something that our IT has to work on and develop that infrastructure, whether it's cost or personnel, to enable it. It's same thing with device management. We went from 10 devices to 140. How do we track to where all of them are? How do we make sure that they're all updated? Can it make sure that this is an automated process, or we work closely with vendors or team members to make sure that there's no issues when someone needs to pick it up and use it? User experience, continuously improving the user interface. Software and hardware. There's always new technology. There's always new devices. There's always new ways of working that me as a company, I want to make sure we look at all those ideas. And that goes into the strategy. Defining a process of vetting new technology. We don't want to be just, looking at one technology. It's always good to have competition, because then it makes people work harder and make sure that we have the best possible solution for what we're looking to do. External site buy-in, when we work with external partners, getting agreement for them to use the device. My company, it took 2, 3, 4 years for IT to just vet the devices, and there's still a lot more to do. So imagine bringing this solution to an external partner, and if they have any issues with it, then we just have to go back to square one, and it really negates that growth. Measuring the impact and value, so that's the idea of making sure that we have a good ROI and that people can see the importance of utilizing this technology, spending the time, having IT dedicate resources on this project, and make sure that there's proper alignment. And in conclusion, I have a lot of acknowledgments from people from all around BMS that have been very vital into buying into the process, evaluating devices, going through that whole thing, and et cetera. We have an extensive IT team that has worked very closely on this project. Apprentice is one of the first vendors we worked with, so definitely they're on here as a big thank you, and all other current and potential collaborators that we have spoken to. So thank you so much for your time, and it was great to be here, and you could feel free to see me in the hallways and ask any questions that you have.
Thank you very much, Noble. We really appreciate your expertise. It's awesome.
Thanks.